Okay, and I think we're going to get started here. Okay, so I'm going to start by just showing you actually one implementation of the drawing setup that I have, which just shows you all the things that we're going to actually need when you get down to it. We actually can draw with an effect. Two-dimensional effects are something that were included in the version of SharpDX that I'm using, which is going to be one of the things that I'm going to have to talk about here. And then also on top of that, we have images. And there's actually quite a bit to how some of this works that I've consolidated. So we're actually going to be spending majority of our time for this looking at what I've called the sprite batch and showing how that works. So there's a couple things I did not implement, and I'm not sure if they worked. That's what this is for. But that being said, most of what I was asked about is pretty much up here. And the one that most people are going to care about is this line and not this line. Because this line, I'm not even sure works, first off, because I've never tested it. Second of all, it's also for a WPF window, and most people will probably be running in native windows. My suggestion is to run in a native window anyways. So, to get started, I am not going to be explaining how to set up your DirectX device. Direct3D device, there are a lot of tutorials on that. You can go to either the SharpDX forums, gamedev.net. They can show you some of the basics of setting up the swap chain and the device, and then getting to the device context. What I'm going to be specifically talking about is setting up the device context for two-dimensional, which is a little bit different. It's actually this right here, this device context. And so, now the thing I need to mention is this I've only seen works in DirectX 11.2. I'd assume it works in DirectX 12. I'm using the libraries for DirectX 11.2 though. Anything before that does not have this device context implemented, and if it's not implemented, there's no way to actually do this quite as simply as I have. You can do it, but it requires a lot more effort. And this is my suggested route for anyone who's going to be working in two dimensionals, just because it allows you to draw straight to the screen. So, that being said, this is working straight off of a lot of the SharpDX libraries, and mainly Direct2D 1 and the DXGI. So those are the two important things that we're going to be pulling from here. So the first thing is you're going to need to have your Direct2D context set up, and I'm going to really quick go actually up to something above this, which is the game window. Here's the thing about working in some of this, and I didn't actually have that. Real quick, I need to reopen the sprite patch. Sprite definition. Make sure that stays as tab. So this is what makes mine slightly more complicated to explain. Is this works on a separate library known as SharpDX.wpf. This isn't one of the base libraries for SharpDX. Therefore, it actually handles my device creation. Because when I grab my And actually, I don't think you can see it here because I even hide it further into the device manager, which does have access to it. Ah, there's the device. This is the actual device. It's an internal thing, and it's from the base code. Okay. Now, that being said, this is all the stuff that happens at launch, and is very, very long of an explanation to explain everything that's done here. But when we create our sprite patch, we're gonna start with the simple constructor, which initializes a factory. This is the direct 2D factory, and you need to use this in some other portions of code to get certain things done. The render target properties, which it pulls from the factory to get some of the DPI and certain things. And this is just so I can keep track of my game window. So, now, what we really care about, though, is going to be, I think, in run. Because it's going to wait until all this is set up. And then we run sprite_batch.initialization, which creates our 2D render target. It creates a properties, which is just the bitmap properties, and their pixel format is this format. This is the format that I have gotten to work. Other formats do not work, as far as I know. This is something that you can look up actually on the MSDN page, and let me see if I can quickly pull that up. And show that. But I had tried a lot of things and ended up just frustrating myself. So this is what I ended up figuring out is working currently. Direct 2D. Yeah, supported pixel formats and alpha modes. So I'm really quick gonna grab window capture. We're gonna grab. You don't want to grab that, do you? Okay. Move. I think I can get this actually. Game capture. Oop. Okay. Well, I guess this will work. We are going to simply grab my entire display. Yeah, that works. Okay, so if you go through this, and this is the page that I grabbed this from, and you look down here, these are supported. This one is the one that I am using, pre-multiplied. This one should work. I've not tested any below this, so there's nothing wrong with using this format. It allows for alpha, 8-bit alpha, 8-bit red, 8-bit green, and 8-bit blue. So that should work just fine. So, and if you should read this if you're going through different things, because it explains when to use different formatting. So this page, MSDN, right up here. I highly suggest looking at this if you want to play around with these settings. Otherwise, the settings that I have should work just fine. Okay. So that being said, that is used right here. And then my Bitmap Options. Where do you actually... So this is just some options that you kind of need to set ahead of time. They were options that I was told I had to set to get it to work. that being said, I got them to work. And if I remember these two settings correctly, these are actually based on my monitor. My DPI is 96 by 96. So that's based on your monitor. You can actually look that up using DirectX or whatever. It's probably not going to stay this way for me. Eventually I'll have it sized based on the monitor that you play on. Now, like I said, this one uses a 2D texture that I'm using to draw to in WPF. That's where it's querying its surface from and setting its bitmap to. That being said, I don't know if this works. I still have yet to test it. This line right here, where it's gonna be grabbing from the swap chain, which is what chain is. So I kind of scroll up here. This is the swap chain. I do have just a tag here just to avoid people from playing with the swap chain when they shouldn't be. But it's just accessing a simple DirectX 11 swap chain. Direct 3D 11 is what I'm using for all of this. So, that being said, when you get back buffer and you're using that surface, that's how you're going to want to be using this. So it will attach itself to the back buffer and draw onto the back buffer. And then you set this target as the target of the Direct 2D context. So now, technically this is not actually the first thing done. First thing done is I set up my DXGI device, which is just interoperability between the different parts of DirectX. Create a Direct 2D device, create the context using the device, and then I just have how it blends set. So this is the setting up of the context and the device, which really just for ease's sake, I'm gonna move up here just so it can be easily read, because that's why I started from the second one down. These two functions handle the entirety of setup. So you go through, make your device, make your context. This is grabbing it from the actual original device, my Direct 3D device. So I query for a DXGI device, and then I give that to the Direct 2D device, and then I attach the Direct 2D device to the device context. And then I just have no options set. Different options is if you're using multi-threaded, there's your multi-threaded optimizations, otherwise just none. The different blend options, add, copy, minimum, or source over. If you want more information on those, again, I'd say go look at MSDN. After it's done with that is when it goes through and binds everything to the actual back buffer of the swap chain. Or if you do use WPF, the SharpDX.WPF, this would be, I think, the line to bind it to the image that's being drawn to the WPF window. So, and then you just assign it as the target of the device context. Now, that being said, that's not everything that will need to be done. Before and after every draw, you're going to have the begin draw and the end draw. This is similar to how XNA did it. So you need to run begin draw from your device context, and I'm making sure that we're not in WPF or we are full screen, because full screen is drawn differently. If you run in WPF, you do not need this from what I know. So, that being said, from what I know. and then you will need to end the draw after you're done drawing in a specific time period. The way I actually handle it in my game loop, which I'm gonna roll down to, where's my actual game loop. So if we go down here, how I handle this, and might be just the easiest way to handle it, I begin and then end. All of my drawing, I never actually call these inside my draw loop because you don't need to call them at different times. Now, mind you, nothing will be drawn until end draw is called. And you may need to play with that a little bit to find when you need to call begin and end draw. I'm not entirely too sure about it at the moment. I think I've got it where it needs to be. And I think you need to call an end draw if you start playing with changing the transform matrix, which is a 3x2 matrix. I have it mapped to the same 4x4 matrix that you use for every other transformations in DirectX for your 3D transformations. You can map them relatively easy to each other, but that's how that's done. Now, this has a whole bunch of different ways to draw certain things in the device context. And not all of them are quite the same as what you might be used to if you, again, are familiar with X and A. But you can combine some things, like there's a draw image and then there is a draw bitmap, which one uses the Direct2D bitmap, the other uses the Direct2D image. I'm not exactly sure entirely the difference between these two, and they are very easily swapped. If you want to be drawing an effect, you're going to be doing draw image. And effects you can attach images to. So the Direct2D effects are all pre-compiled effects. I do not know how to make new effects. It's something that kind of actually bothers me right now, is I haven't figured out a way to be able to create new effects like you create for the 3D effects. But that being said, there are a large number of effects that are pre-made. These are all the effects pre-made by hand. I copied all of these in here. There's a lot of them. So basically, as you go down through all of this, you can get, I'm not entirely sure all of what these do. I'm pretty sure this is, it just adds a transformation on top of it. Don't know what that one does, or that one. Some of these I have really no clue what they do. This is obviously a simple blend effect. Border effect, I would assume adds a border. Adjust your brightness levels. Color management. This one, I think, will allow you to adjust color levels in your image. But the color matrix is the one that would replace the ability to change color of certain things. So, creating composite images, there are a lot of them. If you need a simple crop, it's right there. Blurring, diffuse, adding a diffuse, not gradient, diffuse blur, specular map. Again, I'm not exactly sure what you use DPI compensation for. I list to each of the MSDN articles on them. There are MSDN articles, and they are very good. They show you before and after of almost every single one, so you can see what you can actually do with it. Again, actually, let's actually open up this one, just because. Okay, this is not a fun one. We'll go to one that I know is a fun one. Actually, I'll quickly float up to color matrix, because I know color matrix is a done one. That actually will give you before and after images. So this is the before image, and this is the after. It gives a blue tint to pretty much everything in the image, kind of almost inverting the blues and the yellows. So, and then they give you the actual code in C++ that would do it. This is, if you look, this is the begin draw, the draw image, and then the end draw. Now, if we go back to here, and kind of scroll up, begin draw, end draw, and then they're using the draw image, and they're just passing it an effect. If I remember correctly, you can just pass it an effect without all the extra bits, as these are optionals. I do include the optionals just because it allows you a little bit more fluidity. You can do a bit more, but even still, I still have them as optional arguments. If you want, you can just pass the effect. So, that being said, that's kind of how a lot of these go. If you need to know property names, they give you the property names, and I would just copy paste, changing the different alpha modes. Minimum support required. So this will be, if you use these are the platforms that you can use it for and up. Again, if you're looking at doing anything below DirectX 11.2, which was something that came out in Windows 8. So it would only be at the end of Windows 7, so everyone who has all their updates for Windows 7 and Windows 8. That is the way that I have accomplished this. Aside from this, the only other way that I can plausibly, there is a way to do it that's very painful, which involves swapping things in between DirectX 11 and DirectX 9. Doesn't work too well. The other way is, if you're drawing in 2D, to simply draw three-dimensional planes and add a texture to them. Again, not something I did, but that is a way to solve this if you're looking for DirectX 11 or 11.1. So, that being said, it should be relatively the same for DirectX 12. Again, I haven't checked. I haven't updated DirectX 12. I may eventually do that, but that's not my current goal. Now, most of the stuff that you see here, why I'm casting and stuff, is just because I have overridden a lot of things. Like, actually, if you, the best example is texture. Texture, I will cast as an image, but in the event that I'm actually drawing a bitmap, I still use texture. I have the same overarching class to deal with both bitmaps and textures. And if you notice, I call these all draw texture, just for a little bit more consistency. I understand they're slightly different things, but for most people, when they draw, they won't care the difference between the image and the texture. And they are very similar in how they're set up, because there's an easy way to manipulate in between them. So I'm gonna actually open up. I actually have a whole bunch of different ways to grab it and show it. And they are stored as a bitmap, so bitmap's obviously easier. So where are we now? Explicit operator. So to a bitmap, it just sends its bitmap out. Which that's a different type of bitmap. There's a couple different types of bitmaps that get used. And I am using the Windows, this isn't actually the Direct2D bitmap, it's another one that's actually kind of a middle ground. But the SharpDX bitmap I use, actually, it's just a file converter, not a file, format converter. And I check see if the file converter's ever been used. It's a static, so I don't actually create this for every instance. And then I just use the format converter, which it should be, where are you? Converter, format converter. It's WIC. This is part of native SharpDX. So, anyways, going from there, you do converter.initialize, and this is just when the texture hasn't been written to. I save this and reuse it again and again and again. And this works for both Bitmap 1 and the Bitmap. Some things use Bitmap 1, some things use Bitmap. Image is actually even a little bit easier. I don't need the converter. I go from my Bitmap, and then I just query the interface of image. Again, I'm not sure what the difference between the two is, but there is some difference, which I'm just realizing that I should check and make sure. That it's actually there. That's just a minor thing I didn't actually ever realize that I missed. So that pretty much is everything that you should need to know. Again, you can go through and play with a lot of things, but this allows for drawing of vectors. So if you want to draw an ellipse based on, again, I already have overridden the ellipse, but all they need is they need a center point, a radius x, and a radius y. There's ellipse and a whole bunch of other things. Rounded rectangles, I think actually most of this is actually in geometry. And then they'll need a brush for their color and stuff. So there's a whole bunch of things that you can do with this that should let you draw just about anything that you want to. Because, like right here, rectangle, the brush is just how to draw. You can do linear gradient brushes, radial gradient brushes, so just to give a different effect. Again, if you ever use WPF, the brushes in WPF are basically these. So I would say if you need to look at what they do, just go to WPF and it'll show you the differences, or even Photoshop. The differences between the type of gradient. Linear gradient is going from one point to another, just gradient from there. Radial gradient is out from a center point, and the only thing you control is how far out it goes. And I think there's a couple other types of brushes that solid color brush, obviously, if you just want a simple color. And all I do is I pull a raw color for. And that's actually one of the things, is there are a lot of raws that you'll have to use. So I suggest building up something so you can convert between the normal and the raw. Otherwise you're going to be doing a lot of converting on your own, and that just gets to be a pain. So that being said, like I said, let me scroll up to drawing text here. Text format, which is your font, your rectangles, you need your brush, the draw options actually I think are an enumeration, so and let me real quick. No, it's not going to show me right now. I can actually just do peak definition. So I do actually, again, this is another thing that I override. I try to avoid the need for touching DirectX, any of SharpDX's code, so that's why a lot of this, but these are just some options to clip color font, stuff like that. Measuring mode. So, how does it measure? Okay. That being said, I think that wraps up this video. If there's anything else that you would like to know, actually, one quick thing that I do want to talk about: the matrices. There is an actual, and if I go SharpDX mathematics matrix 3x2, and then this gives you some of the basics. Transformation is going to be scaling your angle that you can do this at. They already have all this set up, so if you're just doing two-dimensional, you can just use the 3x2 and it would be rather simple. If you end up using three-dimensional and you just want to store them as the same matrix, it's not that hard to convert in between them. It's just moving a couple things around. Real quick, I think that's right here. So I actually use pretty much, other than the color matrix, all my matrices are this matrix. So, and it can do all the difference. When you do transformation of your angle, you're going to be doing it on the z-axis, just to be sure, if you do use this larger. And so to convert into, actually that's converting from, convert into the raw 3x2 matrix. Okay. I actually convert it to a 3x2 and then convert it to, where's my convert to a 3x2? Just realizing that I did it that way. This is the simple way. Oh, actually, do I even write that code? No, I don't. So actually, yeah, it's relatively simple considering the fact that SharpDX does it for you. The converting back, it does not do, and nor does it convert all that easily to a nice raw matrix. I don't think. I think I had to write this code. There was no simple conversion for the normal matrix, but for a 3x2 matrix, you convert to your matrix 3x2 and then to the raw. And that's as simple as it is. So storing it, unless you're worried about space in memory that you're using, because this will, I think, over double the amount of space that you use, because the 3x2 matrix will only use up 6 floats, where this one uses 16 floats. So just to keep that in mind, if you're curious about how to go back, this is the normal spaces for it, but if you switch in between these two, these bottom two actually go in the 4th row when you start talking about three-dimensional, because this is scaling. These are your rotational data. So the reason that I actually know that is, for the most part, I actually write most of these scales myself. I obviously don't do the lookats and stuff, because that actually gets really difficult, nor do I know how to do the quaternion. But that being said, it is most of the stuff you can easily do. And they're just math cosine, math sine. So I think that covers all of the important stuff in here. Again, there's a couple different ways to draw certain things to the screen, like text layouts. I've never used them. And I think it's for a little bit finer control on placing your text. You can actually deal with, I think, the spaces in between and all that. which may not be given by the font, but most of what I think was being asked was drawing textures and basic text. So again, just go through your device context, and it's SharpDX.Direct2D device context. This is what holds most of it, and these two things are what make up most of this. Again, factory is actually pretty much just used to create this properties, which I'm trying to remember what both of these are used for. They are used for something. It might be something that I haven't used in a while, but some of this is a little old, so. But these are definitely how you get this to work, and I am sure that it does work. I have actually had this running recently. I'm not going to attempt to run it now because I'm not sure that other parts of this library aren't broken at this current point in time, which may cause crashing. Actually, it shouldn't. So we'll do this real quick. So this is just a basic set of stuff that I've built up, and I'm just gonna create a texture. X. Is that actually what I need for drawing? I think so. Oh yeah, texture 2D is a thing that I use for 3-dimensional. When you get 2-dimensional textures. But we'll do text equals content dot load texture, and I'm just gonna real quick grab something from like my C drive. That's not what I want. C drive, users. Thankfully, my username does not actually tell very much about how to get into my computer with Windows 10. So pictures and no. And this is where it will be found, and then
I am who I say I am.
now you get to know some of my naming schemes for some of my files. So I was annoyed at Google because I had to resave an entire file for them. Okay, now that being said, this is pre-component draw, and then I'm just gonna do sprite batch dot draw texture text. I'm not really worried about anything else. That's why are we set to one of the libraries to be running? I have no clue. A library that I don't actually even use anymore and should probably be deleted. Okay, so set a startup project. So this should just put it in the upper right hand corner. And it's something that I actually just realized won't actually be visible to you guys. Exception! Continue. So I broke something. What do we actually load? Texture files. Did I just name it with a capital P? Okay. Now this is a curious quandary. So we're gonna go start, and I'm gonna run it and let it crash again, because I'm actually curious why it's crashing. Oh!
Inhale.
Okay,
Exhale.
load methods dot add. I don't know when I did this, but apparently I did. Texture, comma, new. Texture loader. There we go. That should make it happy now. I didn't actually add texture, and so it can't load a texture. Occurred. Could not find path. Why does that say J? We're gonna... cause, okay. What we're actually probably gonna do is text dot, or actually text equals texture dot from file. That's why. And this is how I did it last time, because I'm pulling from a specific place, and that's why I didn't need that. I was about to say, I used this not that long ago. Or stupid Google. Google. I apparently can't English today in my typing. There. Build errors. What's the build error? It takes more than one argument. That is very possible. Okay. There we go. There. And I've got to actually throw this up so you guys can see it. Ignore the changing background. We're actually gonna slide this down to on top of Visual Studio. So, and actually, I may end up changing that from a display capture, but that shows that I'm actually grabbing the texture properly and it can be displayed. So, and you can move it around and a whole bunch of stuff, but that shows that it does work. That my loading from file is just some of the things, and actually, if I can really quick, where are we? Texture. I don't think load from file was actually that difficult of an operation when no, it is. But it uses, essentially, it opens a native file stream at the particular location, uses a bitmap decoder, gets a frame. This is code that I found somewhere else. I'm not ashamed to say it. But essentially, it needs a decoder that will pick the very first, it'll pick the image and put it in its first frame. And then I try and initialize my converter that I use later. And this is actually used within inside this. So load from file ret equals texture from this. So, and that's why we use this bright batch, is we look for the parenting game window for it to be a part of, because I use that information later on. So, that being said, this does all pretty much work, and I hope you guys have enjoyed and find this useful. If you would like things like this in the future, just come and ask me. This was asked for by NeonZ27. NeonZ27. I had to go look and see, because he followed me right after he asked the question. So, I hope if he isn't here and he gets to see this on YouTube, I hope he found this extremely useful. If you guys have any other questions, you can just ask them either in chat while I'm streaming, in the comments of this video on YouTube if you're watching this later on YouTube. So I have no problem doing things like this. There are certain amounts of things in this entire engine that I'm not going to sit down and explain, just because one part it would take too long, other part is some of it I'm not sure I want to exactly go through and explain yet, but there are a lot of things that I have no problem explaining. So that being said, I hope you guys have enjoyed, and I'll see you guys next time. If you are watching this stream currently though, don't leave.